Next form that we will study is the normal form. Okay, what is the normal form? What is normal? It is the perpendicular drawn on the line from the origin. Okay, let us say we have got this line here. Okay, this is the line L. So if I drop, this is origin. If I draw this perpendicular on this line L, then I am talking about this length here. Let us say this is P. So this is normal. This is given, the length P, or length of perpendicular drawn from the origin to the line. It is given. So in to write the equation in normal form, there are two things that are given. Length of perpendicular from the origin to the line, that is P, it is given. Second, the angle that this normal, this is the normal, right, makes with the positive direction of x-axis. Let us say this is the angle omega. So there are two things that are given: length of perpendicular from origin to the line L, of which we need to find the equation, and omega, which is the angle made by the normal, not the line, right? Angle made by the normal with the positive direction of x-axis, with positive direction of x-axis. Okay, now this line can be anywhere. For example, this line may be like this. Okay, in that case I'll have to drop this perpendicular like this, and this will be P. All right, and with now this normal will make an angle with positive direction of x-axis like this. This will be omega then. All right, or this line can be here, it may be here. In all the cases I'll find a general equation which will be okay for all these orientations of the line. All right, so P is the length of normal or length of perpendicular, and omega is the angle made by the normal with the positive direction of x-axis. So let us consider this line for finding the equation in normal form. Let us say this is line L. From this origin, let us draw this perpendicular like this. This is omega, and this length here is P. Okay, if I join this point, or if I drop a perpendicular from this point here like this, so, and if I ask you what will be this length here, you will say P cos omega, right? This is what we know. Or you can find cos omega and see this line will be P cos omega. And what will be this length? This will be P sin omega. Okay, if some of the students don't know about it, they can draw a triangle like this. If this is P and this is 90 degrees, then what will be this length? They can take it as A, or this as B, and then find sine omega and cos omega, and then you will see A is nothing but P cos omega and B is nothing but P sine omega. Alright, so this is P cos omega and this is P sine omega, and this is the coordinate axis that I have taken. So what can you tell me about the coordinates of this point? These coordinates will be, because the abscissa is P cos omega and ordinate is P sine omega, the coordinates of this point will be P cos omega comma P sine omega. And you can notice that this point that I've got lies on this line L, right? Lies on this line L. So one of the information I've got, I need two information to find the equation of this line. So one of the information I've got a point that lies on this line. Now this line is perpendicular to this line, right? This obviously it is the normal, so it is perpendicular to line L. Now slope of this normal is tan omega, right? Tan of the angle of inclination. Now what will be the slope of this line? this line being perpendicular to it, the slope will be negative reciprocal of it. So slope of this line will be minus 1 by tan omega, right? So the slope of this line will be minus 1 by tan omega, or if you want to write it in form of sine and cos, tan omega is sine by cos, so you can write it as minus cos omega by sine omega. So now I've got two information. I've got the slope of line L and one of the points on this line. So point slope form of the line is y minus y naught, which is the y coordinate of given point, that is p sine omega in this case, equals the slope, which is minus cos omega by sine omega, into x minus x coordinate, that is p cos omega. All right, now I'll solve it further and find the equation required. So let me multiply this sine here. It will be y sine omega minus p sine square omega equals minus cos omega x, and this minus minus plus p cos squared omega. Okay, so now let me bring this on the left hand side. So it will be x cos omega plus y sine omega on the left hand side. On the right hand side, if I bring this, I can take p as common, and inside I'll have sine square omega plus cos square omega. Now this expression is equal to 1, right? So what I'm left with is x cos omega plus y sine omega is equal to p. So this is the equation of a straight line in normal form, where the length of the normal is p and angle made by the normal with positive direction of x-axis is omega. So this is the equation that we were looking for. Okay. Before proceeding to the questions, let me tell you something else. If I, let us say, once again draw this line L, and let this be the normal, which is P. Okay, and this is the angle omega that this normal makes with the positive direction of x-axis. I'm just looking at it in another way, like method 2, to find the equation. Now you see that this is a right angle triangle, right? This is a right angle triangle. Similarly, this triangle is also a right angle triangle. So if this is omega, this will be 90 minus omega. This angle will be 90 minus omega. So what will be this angle? This angle will again be omega. Now once you know this much, and you know that this length here is p, so you can find this length. What will be this length? See, this is opposite 90 degrees, so it is hypotenuse, right? This is what I mean to say. If you have got a right angle triangle, let us say, and this is the hypotenuse, and you have got this perpendicular, okay, this is opposite 90 degrees, and this is one of the adjacent sides, and this is the angle I'm talking about, omega. Then what will be h in terms of p and omega? See, if I take, let us say, cos of omega, it will be equal to p upon h, adjacent side upon h. So h will be equal to p by cos omega, hence it will be equal to p secant omega. So this is my hypotenuse, which in this case is this is the hypotenuse, right? And this is the length of normal, and this is the angle. So what will be this side? P secant omega, right? Now you can tell me about this length here. This is omega, this is p, right? So this will be p cosecant omega. It will be p cosecant omega. Why? Because this time this omega is here in this triangle, right? So if I take sine of omega, Sine of omega, it will be opposite by hypotenuse. So hypotenuse will be p by sine omega, right? So I can write it as p cosecant omega. I hope you understood this, that if this is length of normal and this is 90 degrees, this is omega, so this length here will be p secant omega and this will be p cosecant omega. What is p cosecant omega? It is the y-intercept. What is p secant omega? It is x-intercept. Now we can write the equation in intercept form, which says x by x-intercept, which is p secant omega, plus y by y-intercept, that is p cosecant omega, it is equal to 1. So this is the equation in intercept form using the length of normal and the angle. So if I bring this secant omega in the numerator, it will become cos omega. So x cos omega plus y sin omega, and I will multiply the p, this p on right hand side. So it will be equal to p. So x cos omega plus y sin omega is equal to p. This is another way of finding the same equation that we found here. Right? If you are confused how I wrote this as p cosecant omega and this as p cosecant omega, you can start with taking cos of omega, and then you will see that this length here is p by cos omega. So you can write it as p secant omega. Alright? And similarly, you can find this length as p cosecant omega yourself. Alright.